All right, in the previous part, we wrote an echo server that used coroutines to achieve concurrency. Essentially, we had some code that could handle like multiple client connections. At the same time, it did not use any threads. It was using these magic async functions and the await keyword. If you look at this code, it might just look completely magical as far as how it works. And if you actually dig beneath the covers and try to find out how it works, your head will likely completely explode. So what I'm going to try to do in this last section is just talk a little bit about the machinery that is actually making this code work, to give a little clue about how it's put together. And to do that, I'm going to go back to the original example of doing a coroutine function. Going all the way back to that, you can define a function that uses this async keyword. Like I could say async greeting name, return hello plus name, like that. Just to reprise that, if you call this function, like you say greeting Guido, it doesn't actually do anything. It just creates a coroutine object as a result. The only way that you can make that run, again, is to drive it with some other library. Like maybe you use the async.io library where you get an event loop, and then you do this run until complete, and then you get a result. So the first question that just comes up is, what is that run until complete thing doing? Like, what does it actually mean to run a coroutine function? So here's what is actually happening under the covers. If I say g is equal to greeting Guido, the way that that code gets executed is Python executes a send method on it. In fact, it sends in none. And you will see the code immediately stop with like a stop iteration exception. Okay, you get a traceback, it says stop iteration. And then the really odd thing is like the exception actually has the return result in there. Well, that's really weird. In fact, actually, the way that this code would run is you would make a coroutine like that. You would then do a try statement where you send in a value, and then you would catch the stop iteration exception, then maybe print like the result would be equal to the value of that exception. I mean, that's bizarre. You might look at that and say, well, that's just crazy. What in the world is going on there? I mean, it's like layered on top of stop iteration. The fact that you're getting a stop iteration there is maybe a clue that this is somehow tied to the yield statement. So remember that you could define a generator function. Like you could make a generator, for instance, where you said, n is equal to 5, while n greater than 0, yield n minus 1. This is something that normally what you would do is you would call that, and then you would do a for loop on it and drive it with the for loop. Turns out that there's an extended use of the yield statement that is in play here. One of the things that you can do is write a function where you can use the yield statement to emit a value, but at the same time, the yield statement can produce a result. This is going to look odd, but it's kind of like you're emitting and receiving a result kind of in the same step there. I'm going to put a print in here. I'll just say got the result. And maybe I'll increment the n just to kind of have something different each time. This is a very kind of different use of the yield statement here. I'm going to go ahead and make one of these. Okay, so it comes back, says I'm a generator. If you call next on it, what happens is you get a value popping out. That's what happened in the first yield. But what happens now is you have the ability to send in a result back. So if I were to say c.send, like hello or something, what would happen is the function will wake up and it will receive this thing that I've sent in there. Okay, so it said that it got the result hello, but then as a result of the send, it's actually emitted the number 1 at this point. So what's happening is you've got this function where it's emitting a value and it's receiving a value kind of all at the same time. You might look at that and say, well, that's crazy. Okay, so what in the world is going on there? This is the mechanism that is driving the async and await mechanism in Python. It's essentially, it's a layer on top of generator functions using yield. Now, these details are actually hidden from you. You're not supposed to kind of worry about this. I mean, what you care about is you would define, more the high level function using, async and await. You don't worry about these underlying details. Now, let me show you that code again, the network code. we're going to talk about a little bit about what is going on here. Okay, so we have these async functions. Under the covers, they're actually layered on top of generators. Again, that's a detail that you're not supposed to worry about. But I want to focus on these operations like the sock accept and the sock receive and the sock send all and so forth. What is happening there is Python is using a very specific type of function definition to make that operation work. And here's what it's doing. I want to leave the code over on the left up just so you can kind of look at it and see what it looks like while I'm doing this. So what those operations are is they are sort of defined in a slightly different way. There's a types module that I'm going to import. And what I'm going to do is declare a special function as a coroutine. I'm going to make a function sock receive, where you give me a socket and a max size. And what is happening in here is Python is actually using this kind of extended form of the yield statement. What it's doing is it's going to get a result, where it's going to say result yield, and then what is passed to the yield is some kind of like request. Like I'm going to make a request maybe here, like I want to receive on some socket max size. And then what it's going to do is return that result. This sort of special function that I've defined talks to the code that's actually going to drive a coroutine. So keep in mind that everything that's going on here over on the left is kind of being driven by this event loop that's being created. They have this code that's driving that. Here's how that function is going to get driven. So if I were to say like S is equal to sock receive, I'll just say like some socket 10,000 like that. It comes back and says, okay, this is a generator object. If I send in like none, for instance, it comes back and says, hey, I want to receive on this socket. What's happened is that the code is actually stopped. In some sense, it's like making a request to this like event loop that is running. And then what happens is that event loop will look at this and then decide how to fulfill that request. When that request has actually been fulfilled, it will then send in a result saying, hey, you got some data. And then that coroutine will finish running. What happens in this code is that essentially somebody has made a little class like this event loop object. So let's go ahead and make a class. I'll say, here's a loop. And they have defined different operations on this as these coroutine objects. There's maybe a method sock receive, where you give me a socket and a max size. It's going to do some kind of yield statement in here to make a request, and then it will return a result back. And then the same thing is done for the sock like send all. Okay, so we're making little requests here. Return that back. And then here's how this code gets driven. I'm actually going to try to manually drive that code, sort of faking it, if you will. I'm going to import from that module the echo handler function. Okay, so what I'm doing is I'm focusing on this echo handler here. Here's how this is going to be driven. I'm going to go ahead and make like my little loop object here. This is like my fake loop that I've made. And what I'm going to do is I'm going to make this echo handler coroutine. I'm going to say, okay, you're an echo handler, I don't know, we'll call it some socket, and I pass in the loop. The loop is going to drive this coroutine by doing send operations. It's going to basically go to that, and it's going to say, hey, I'm going to send you none. And the code is going to run until it hits this yield statement. There's a little bit of a weird path in getting there. I mean, it's like it comes into this code, it's doing a while loop, it's doing this await, but it hits this sock receive statement. When it hits that, it essentially yields a value. And this is what it's yielded. It's sort of said, hey, I want to receive from some socket 10,000 bytes. Now, at this point, because I'm in the driver's seat, I can decide how I want to handle that in any way that I want. I could take that coroutine and set it aside for a while. I could go do something else. There's any number of things that could happen, but the code on the left is not going to run again until I send in a result of whatever this operation is. I can send in a result. I could say, well, okay, let's say I sent in the text hello. If I send it in, what's going to happen is this code on the left is going to start running again. This result hello is actually going to be the data that comes back there. Okay, so I do a send. What's going to happen now is the code is going to advance to kind of the next await statement. What you're seeing is the code is stopped and it's saying, hey, I want to do a send all on some socket. Now, by the way, here's the data got hello. Okay, so it's waiting for that to happen. If I want to continue driving the thing, I do it through a sequence of these send operations. So what's happening is you're getting kind of this back and forth between this coroutine and whatever is driving this event loop. It's a very kind of interesting approach, but one way to think about it is that, again, this code on the left is running entirely under the management of some other piece of Python code. And underneath the covers, the yield statement is being used to suspend that code and make requests back to the event loop. So this is a very kind of small taste of how this is actually put together under the covers. The actual precise mechanism for this, by the way, is like in async IO, is actually different. Like the actual mechanism for making a request, there are many different ways of doing that. Like here, I'm returning a tuple that represents a request. Async IO actually uses a completely different object for that. The underlying machinery is kind of the same. It uses the yield statement, but these are all low-level details you're not actually supposed to worry about. As kind of a final comment on the async stuff and the coroutine stuff, in order to make sense out of that, it really is kind of maybe best to focus at kind of the high level. You write these async functions, you use the await statements. You should know that there are libraries that are going to run that code, like async IO can run it. Underneath the covers of that, it is based on generators, it is based on coroutines, but that is an implementation detail. In fact, the less you think about that, probably the better off you will be. It's almost maybe analogous to like machine language or assembly language or something. It's like, yes, your program does run on machine language, but you're not really supposed to think about that. And I think you should take the same approach for sort of the generator stuff that we just did. But it is kind of interesting to know that is how this works.